So I guess by now you've heard about digital twins. We have a service here at Microsoft called Azure Digital Twins that allows you to manage lots of data coming from different sources and use graphs to query that data in a very smart way. But who better than Rick here from Willow to tell us all about Azure Digital Twins and how important are these graph queries and how they can really help you navigate these complex data sets. And that's today on the IoT Show. Hi, everyone. Thanks for watching the IoT Show. I'm Olivier, your host, and today we will talk about graph queries in the context of Azure Digital Twins. And for that, we have Rick from Willow. Hey, Rick, how are you?
Hello, doing well.
So, Rick, tell us a bit about yourself before we get into that very interesting topic. Who are you? What are you doing, for a living these days?
Yeah, so I'm the product and technical lead at Willow for our Microsoft partnership. So I get the joy and pleasure of working closely with a lot of the Microsoft IoT product team, as well as our internal Willow product team, and helping us build amazing product on top of the Azure ecosystem.
So for those who don't really know what's going on here, what does Willow do? What is your realm and what is your expertise?
Yeah, Willow is the digital twin for the built world. So we provide amazing products that leverage digital twin technology, pulling in data from IoT sources and actioning the data through intelligent workflows. And we deploy across many different industries: real estate, rail, mining, smart cities, and a number of others.
Yeah. So if I were to say you guys are at the edge of that new trendy thing that is called the metaverse, that we do call the metaverse, I had to place it somewhere. But in a nutshell, you really are, you were an early adopter of Azure Digital Twins for that very reason. So you are in that business of merging data from different sources and try and make sense of that data to offer it as a service to your customers, right? So someone wants to manage a building, they need to have information from the various devices that are in that building, offer in an intuitive and functional UI and interaction to the operators, to the tenants, to whoever is around this building. And so that's a complicated space. Well, how's it been so far using Azure Digital Twins? The product has been out for not so long, and you guys have been, on the very first private preview versions of that. How are things going with the product?
It's been going well. Yeah. So as you mentioned, when the product was released for into public preview last summer, we did an assessment of Azure Digital Twins to make sure that it would be fit for purpose for delivering value to our product and our customers. And it's been great. As you mentioned, one of the key things for us is it has been a challenge across the industry in bringing together disparate data sources. Everyone knows that there's value in it. It's just the journey of bringing those together, both in implementation and solutioning, is a big challenge. And the promise of digital twin technology like Azure Digital Twins provides, with that underlying graph database, the ontology, which helps you normalize data across disparate data sets, really unlocks incredible potential. And we're coming up with new use cases on a daily basis, and ultimately driving value for the end customers.
So you already alluded to a couple of these, but there are other graph databases out there, right, that will allow you to do similar things that you can do with Azure Digital Twins as a service today. That allow you to create these twins where they have, a set of properties for things, for a group of things, and then the relationship in between them, and a set of graph queries or a graph engine that allows you to query that data. But what are the specific things that stand out for you in Azure Digital Twins that made you pick it as your preferred database here?
Yeah, it's a great question. I mean, we did a pretty thorough analysis, and a couple things that jump out were Azure Digital Twins is a platform as a service as opposed to a database. And so some of the things that we get to take advantage of there are built-in eventing being native IoT, so things like ingesting natively IoT sources. But really, the big one that jumped out to me was its knowledge or treating ontologies first. So a typical off-the-shelf graph database can be used to model anything in the world, or you can use it to develop social media connections or whatever. But for us, being able to load in ontologies, regardless of the domain, whether it's real estate or rail or whatnot, really makes Azure Digital Twins easy to work with. It's load in your ontology, start creating twins and relationships, and you're off and running.
Got it. And so ontology are the things that are very industry specific. So when you're a software developer, you might not be super aware of data models and so on that are proper to a specific industry. And then you have the graph queries themselves, and we'll talk more about these ones and how important they are. Having the service allows you to access that data coming from various sources and that is modeled in different ways is super powerful. But for people like me who are not super aware of the details, what are the key challenges and why are graph queries useful and important?
Azure Digital Twins, as I mentioned when we started working with it last summer, allows you to create incredibly accurate representations of the real world. And so you create twins that are nodes, relationships connecting those twins together, and you can do that very granularly. The challenge comes then when you want to fetch that information back out of the graph by asking a question or a query. Mm-hmm. And for us, it was actually a challenge. We realized that we were creating more nodes, more relationships than we could actually answer questions for, even though we knew that we had questions that our products wanted to ask. And we worked closely with the team at with Azure Digital Twins. And as of about a month ago, they released a new match query statement, which is essentially based off of the open Cypher query language, if anyone's familiar with some of the graph query technologies. And it allows us to answer some really tough questions like things that are variable hops away in the graph or based off of a model or an ontology.
So let's look at some examples of these specific queries that this new types of queries allow you to do, and let's discuss as well. What are the differences and what would happen if you didn't have them if you were working with regular, SQL type of queries?
Yeah, it's always great to look at examples. So I've got a couple here. The first one is really geared around, let's say you're trying to develop a query for a rule. Let's say you want to write a rule and you need to be able to pull some twins out of the graph. Traditionally, what you need to do is basically write out every rule line by line and do a bit of an ID mapping. This ID matches to this ID. So if you, in this scenario I have up here on the screen, you might say occupancy sensor located in this room that's connected to a lighting control system needs to be able to control the thermostat that's also in the room, but it's connected to the BMS or HVAC system. So two completely disparate systems, but you want to, develop a smart rule that allows you to save some energy if someone leaves the room. That's very labor intensive. And what we're able to do with a graph query is something like a statement that looks on the right, which is a kind of a natural language way to describe that. And in the next slide, I'll actually show you how we actually leverage the match query statement in Azure Digital Twins to write that out.
Okay.
So here's a little bit of under the hood. Imagine each box here is a node or a twin in our graph, and each line with an arrow is a relationship. And so the first part of this query is hey, this occupancy sensor has changed to vacant. I'm up here in the upper right-hand corner, and we want that to be able to control the set point for the room. So the first part of the statement was for that occupancy sensor, I want to find the related room that it's serving. And so we traverse the graph, and I've written out the actual query statement in the bottom right here, but we essentially traverse the graph to find a room that it's a part of. And then the next part of the statement is for that room, let's find which terminal unit conditions it. And what I love about this example is you can see here, I just matched on a fan power box. But in my query, I actually said to find a terminal unit. And I've introduced a little snippet here in the bottom left, which is our ontology, which is to say the query actually understands inheritance of your modeling ontology. So this is a super powerful example where we have a twin of a fan power box, but the query said, find me any terminal unit, and it found the proper fan power box.
And is it fair to say that you would have to go through many hoops if you wanted to do that with, you know, regular database and regular queries, right?
Yeah, the power of the twin here is that you're literally just traversing and writing your query exactly how the data is structured. And in a traditional kind of SQL or relational database world, you end up finding the need to create a lot of many-to-many join tables, and it just gets very messy very quickly. And as you try to take that solution and make it scalable for different implementations, it becomes very challenging. And so this just very beautifully allows you to express the question.
Yeah, and another thing to mention, you once again already alluded to that, but the data we're seeing, as you were saying, like comes from different manufacturers of different types of devices, and you still are able to access, you know, that information from these various sources, you know, seamlessly without having to change your queries or adapt the twin itself. It's just like, hey, there's that twin is there, and its properties, its relationships are defined in my graph, and I can just access that. It's pretty powerful. Do you have other examples?
Yeah, I've got one more that I like to show, and this is kind of where we're heading a lot with our product, which is the ability to search, and especially getting into things like natural language search and chat and everything, is this idea where you want to ask a question of your environment. You don't always know ahead of time what that question might be. And up on the screen, I've got some question types or search classes that we might be searching for. And these are all very challenging in a traditional non-graph or graph queryability type of scenario, which is like understand siblings, search by variable depth, search by a distance, shortest path. These are all very challenging problems to solve for. But the graph query allows you to do that. And so if we look at a couple examples here of a variable depth search, we might want to say something like, find me all air handling units that are located on the roof. And in a relational model, we'd issue that query, and it might find 5 results. But the actual correct answer in this case I'm showing is 83. Because we have a variable hop, there might be an air handling unit that's in a penthouse room that itself is on the roof. And so it found some additional air handling units which match the query.
I see. So in the first case, you're pretty static, basically, in terms of what the structure of the data is expected to be. When you're using the graph query, you can actually access a more dynamic model or a more dynamic architecture here.
Yeah, and there's different scenarios. Like many of our customers have different levels of fidelity in terms of their understanding of their environment. And so this, with a single query, allows us to be able to access both low fidelity and high fidelity implementations very easily.
Wow. That's a huge difference, though, because like the first one literally gives you false results. Yeah,
it does. Yeah, and so that's what's very powerful about that, is it can be misleading. And this is just to kind of show a similar under the hood of what's happening. As you find maybe 3 air handling units in my little mini subgraph here, the first thing that you're going to ask is to find out which ones are located on the roof. And in the upper left here, you can see that it actually takes 2 hops to say, yes, this is in fact on the roof. But the middle air handling unit here is actually just 1 hop away. So both of them are valid responses that you would need that variable hop query to answer.
Yep. And once again, I bring it back to the traditional query. You would have to know in advance that there are potentially units that are in a room on the roof for that query to work. Anyways, so that's part of the power of this graph queries too. And these hops are done automatically, right? So you basically have this query that is written there once, and it will figure it out, right?
Correct. Yeah. In the match query statement, you essentially include an asterisk, and I'll show an example of what that looks like on the the next slide here, but by including the asterisk, you're telling the query engine to basically dynamically hop a certain fixed number of amounts, and it'll keep traversing until it finds a match.
Nice, love it.
And yeah, so if we have time, I just have one really I get excited about this example because it introduces a new data set. So what we have here is a question that you might want to ask, which is find which tenant leases space on floors served by a particular water heater. And you may be needing to ask this question because you need to do service on the water heater. There's been a complaint or an issue that I'm not getting hot water in a certain restroom, and so I need to do service on it. But before doing service, I want to be able to notify the tenants that are going to be affected, which seems like an easy question, but oftentimes a water heater unit may be installed 6 floors up centrally from the actual restrooms that it's serving. And so here in my graph, I'm going to start with the water heater node, and I'm going to ask the question, find assets that it feeds. And so I traverse the graph again until I match on several sinks and a shower. And the next part of my query, which again is written out in the bottom left here, and you'll see some asterisks involved with the dynamic hops, is find which floors those are located on. And again, we're doing a dynamic hop, where in some cases it takes 1 hop, some case 2. Mm-hmm. And we find out that level 4 and level 5 are being served by this water heater. And then the last part of the statement is pulling in the leasing data. So this is where I mentioned a really cool use case of I know leases and who's leasing which spaces. And so I'm actually going to find which companies are leasing space on that level, which again is traversing another 3 or 4 nodes in the graph.
And not only is it traversing nodes on the graph, but once again, I repeat, the data is on and is placed in different areas, right? So like the tenants and who's renting the spaces is not an information that the building management group or company knows about, and so that's something that through digital twins and through that graph was put together, put in relationship, and now is able to be accessed through these queries for the applications to offer an operation that is seamless.
Yeah, and we've got a analytics team that's constantly building these queries and producing BI charts, et cetera, and they love this because they're able to write a single query again that applies to and our product can apply to many different scenarios depending on the fidelity of the graph.
Nice, love it. And so you guys, well, first of all, Rick, thanks for coming over here, because that's great that you came and shared, your perspective on graph queries, how important they are, and how Azure Digital Twins is working for you guys. I know you have a repo that will help people, if they don't trust you, right here, they can go and check it out on their own. So that's the link below. Can you just walk us through real quick through that repo so that they know what to expect?
Yeah, absolutely. So all of our ontologies are open sourced, and we work closely with the Azure team on adopting their open source ontologies. And so this is just an example of our real estate ontology, Open Digital Twins building. Mm-hmm. And in this page, it's got a README about how to get started, working with it, understanding the data sets. And you can see here to click here and find out more about the real estate core ontology that we're built upon. And this is a great resource both internally for Willow employees as well as all of our customers, because you can understand the types of data sets that we work with. And we even have some really amazing examples of what we just saw, which are samples of different scenarios. And this really helps you understand how different twins are connected and interacting with each other, and really allows you to shape and form some of those queries that we looked at.
Nice, fantastic. Rick, I think it says it all. That's perfect. Go check out the GitHub repo down there. Hope to see you soon again on the show, Rick, because I know you have way more to share about Willow, what you're doing, and digital twins in general. Everyone, thanks for watching the show, and see you soon.
Thank you.